Okay, now I want to talk about this topic called compositions. And here is a diagram made just to show you what that is. And this is something that might take a while to grasp. But once you get it, I hope you get it soon, sooner than I would hope. Because this is part of the mini project you're writing for the next week. Okay, so a composition is really just a relationship between two classes, okay, or two or more classes. And another type of relationship between two classes is called inheritance. Okay, if you talk about inheritance, maybe that's something that is easy to understand. Is when a class is a subclass of another class. Okay, so that hierarchical structure forms this parent and child relationship between two classes. And then when we do something like that, then we say, say I have a class here. I don't have an example here. Wish I have another diagram. I think the book has it. In chapter 1 talks about dogs and pet, right? Inheritance. So the parent class is what's called also called a superclass or a base class, okay, or a derived class. There's a lot of names for those. So any of those terms you hear, the parent class, the superclass, the base class, derived class, they all mean the parent class. Okay. So and then underneath. So if you think about, I don't have the diagram here. Maybe if I were to just do something here. I have this somewhere, I know. Okay, well, maybe we'll talk about that later because it's confusing. We won't be talking about inheritance until like chapter 10 or something. But anyways, is the relationship between a child and a parent class that forms the inheritance. Yeah, if your parents are tall, and you also inherit the tall. All right. Yes. So it's exactly like in the real world, except I'm not sure if you want that in the real world or not. But in the programming world, means a parent and a child class, the child will inherit, will own everything in the parent class. Okay, and yeah, let's see if I do a new drawing. Let's see if I can do it down here at the bottom. Thought I had it somewhere. Just do it down here. If I can insert a drawing, okay. And so if you have a parent class, this is called a parent, and then you have a child class, okay. So if the parent has like A, B, and then C, whatever those are, it'll be like, any data. Then the child also has those two. If the child is a subclass of the parent class. Okay, so that means that the child, because it has this relationship going on between the parent and child, parent has A, B, and C. So the child also has A, B, and C. It inherits everything in the parent class. A, B, and C means like functions, right? Or methods or data fields. Yeah. Correct. Yes. It's only one way. Okay, so it doesn't go the other way, unlike in the real world, of course. Right? But I mean, it's a nice thing. It's also a scary thing. It is in the real world. Imagine your parents have everything, go to bed, you own everything, right? That's horrible. But so right, it's just one way. So that means in the child class, I'll put here like A, B, and C from the parent. I also have like D and E from me, from the child itself. So these two could be like, I put a dot here. So these are from the parents, plus the child has D and E at its own. So usually in terms of programming language like that, so the child class is always larger than the parent class, because you can expand more to it, right? Equal or more than the parent class. Like you said, the parent cannot inherit the child class, so it will always be limited to whatever it has. If you expand it to have like X, Y, Z, it's automatically for the child as well. So it'll always be larger than the parent class. And that's also another way you can tell which is the parent, which is the child. So this is what's called a inheritance, and inheritance has this thing called is a relationship. Okay, so it forms that relationship from the child's perspective, not from the parent, from the child going up. So the child is a child of the parent. So if the parent is a pet and the child is a dog, then the dog is a pet, right? But we don't say a pet is a dog. A pet could be a parrot, right? That's why we don't go the other way around. It's always on the bottom up. A parrot can be a pet. A cat can be a pet. A turtle can be a pet. Okay, so it's a relationship. This is for inheritance. Okay, so when we talk about inheritance later on, this is what it means. And then there is the other relationship. We call it, I'll use the same diagram here. I'll add over on this side another shape. And this could be another class. Maybe it's just like a car. I'm not sure it makes sense, but maybe not a car. Let's be more specific. We could have like a human, right? Is it human? A person. Person, and then what is this thing? Oh, like a human. Or living being, right? Living organism. I think we are. I don't know. Okay, so over here, I have a class, we call it a heart. Okay? So, this class, I will just draw a line here for so you can see. So, a person has a heart, right? So, this relationship is called a composition. Composition has the relationship called has a. Forms that type of relationship. I think I did it correctly. I wish I could have it a little bit nicer for them, but I will. Okay, so has a relationship going this direction. It's called has a relationship because a person has a heart. And if you go the other direction, then we call it differently. I'm going to draw it here. Oops. If it goes that direction, then we say part of. Okay? So you can say a heart is a part of a person. A person has a heart. Okay? And then if you talk about inheritance, that means a person is a living organism. Living being should be full living being, but so we have this kind of relationship. And this one here is what's called a composition, because it is composed of something. So the person's composed of a heart, composed of a lung, composed of arms and legs and hands, right? Like those. Now a hen is a part of person. Okay, so you have that relationship there. Now these two terms, has a and part of, they have a different name as well, and that depends on the, I should say, the length or the no, not length, the strength of their relationship. Okay, so this part I put down here is a composition, and up here I'll put another separate term. We call this one here aggregator. I'm not sure the book has this term here, but so the aggregator and composition, you have those two terms, but really the overall picture is it has a relationship, because if you look at it from this person's perspective, it has something. It is not is, it has something. So composition is has, and then inheritance is going up the class. Okay. So when we declare a class like this, then this arrow is not really like, you're not extending from here. You're actually a part of this person. So really, if I were to redraw this heart should really be inside, right? Because it's part of that object. It's really inside of that person. But because it's a separate class, we draw it outside. Okay, but inside here really it connects to an object called heart of the heart class. Okay, does that make some sense in terms of how these objects are related? Okay, so when you use a class as a data field inside another class, we call that composition. When you extend another class from this class, we call that inheritance. So extending to the parent class. So this one here, and I'll show you how you do that in the code. And in the note as well, I have a another diagram with the lecture notes here. Maybe a better diagram to show you about those relationships. Just don't crash on me now. Right here. Okay, so the association is another, right, so this relationship between two classes. We have the aggregation and the composition. Now, so the aggregation is more like it has a, and the composition is like the part of, but really it just formed this huge called has a relationship. The aggregation and the composition is really just depend on the strength of these relationships, how weak or how strong they are. So a class between, so class A and class B, back here, the person in the heart class, okay, if it's an aggregator, then it means that this class person and this class heart, they are independent. That means they can live by themselves separately if they're not attached to each other, right? So in this case, it's not. So a person cannot live without a heart. A heart cannot survive without being a person. So therefore, these are called very dependent classes. They are called composition. Okay, so it's that strength is very, very strong. One cannot live without the other. Like Harry Potter thing, but okay. So that is a composition. The aggregator is kind of similar. It's a little weaker type. Like you can still have, like, for example, a company has employees, right? If the employees all quit, well, the company is still there. And vice versa. If you close the company down, those employees are still, there's people, they are still there. So they're still completely independent of each other. So that is what we call the aggregator, because the bond is much, much weaker. So that is the difference between the two here, but mainly it is a in simpler terms, it's just a composition because the person is composed of the heart and other objects. The company is composed of employees and vendors and government and things like that, right? Well, not government, but bills. Okay, so now back in the code, I'm going to write a program to illustrate the composition so you know what that's like. And we'll create a new unit here, a new project. Call this unit 4. And package, we'll just call it composition. Be lowercase. Okay, and then I'll write a class. This will be just a main class, so the main program with a void main to start the program with. And we're going to write, I'll use the school example. Okay, so we'll create a class called school, just the class school. And we'll also create another class called student. Okay. So student class, what do they have? I mean, some characteristics about student. Right? ID, name, is that right? Yeah, so we can have like maybe private int ID. Assume it's all only that. And then private string name. And so on. You can do as many as you want. So I can just use those for now. And we'll create the setters and getters for those two. So again, source, setters and getters. Okay, so let's just say that we have those two fields for the student class. And you can build on this if you want. Then in the other class, the school class, we're going to have some things that are related to school. So again, we have the school name, right? So private string name for the school, private, maybe the school code of type integer. But not only that, you have the school full of students, right? So you have student. So instead of string or integer, we have the type of student. Maybe student 1. Okay? As you can see, this is a variable of the data type student class. Just like the string, it's a capital S, just like string. It's a student. Instead of the integer, you have student class. So this one here is a composition because it's composed of another class called student. And this example, we just have one student. And then now you can still do the same thing. Right click and setters and getter for these, just like you did with the other one. Except the student will be the student type instead of the other type. So the data type will be student for the return type because I'm getting the student object out of it. Okay. But the rule still is the same. String, public student, get student, public void, set student to student 1. Okay. Remember that student here is an object. So really, when you create this object, student here, it should say new student. Okay. So it has a new student object. And the student has two fields, student1 dot ID, student1 dot name, right? It has more functions, and you access those directly. Yeah, because this student class is over here, right? So if you go back to my other diagram, which I don't have anymore, yeah, I think I lost it. Yeah, I lost it. Yeah, so over here, so you have the school class is composed of student1, and student is a separate class. Another one is you can have the faculty class as well. So school is composed of faculty too, right? So another faculty object here will reference the faculty class. Okay, so the school is composed of a student object and a faculty object. So a composition. Now, in this example here, if there are no students, there's no faculty, well, the school still exists, right? They can survive. And if the school is not there anymore, yeah, the student can still exist, so do the faculty. Because they're not really strong in the upper bound. So, and then in the main program, I'll create the school objects. So one school is a gateway. This is maybe, MATC. This could be a college, right? And because they're school classes, they have the same blueprint, have the same data here for the faculty and the student. So my program starts in the main program here. And because these are all like classes, I can have student and faculty objects too. I mean, for whatever reason, but I just say you can. It doesn't mean you can't. Okay. So following this diagram, then we have the school as a student1. And then you could create another class for faculty, exactly the same as this, and then call it private faculty, faculty1, whatever. And then in the main program here, this is our main program starts, so we're going to create a school. So school type, we'll just call it school1, is new school. Okay. So when you create that school1, it goes into the school class. Okay, it calls that object, that constructor, which we don't have. Java calls that blank constructor, creates that school object. The school is up, and then it has a name, has a code, and has one student. Okay. And if you access the student, well, you have to call the student's class to get the name and the ID. So you have to reach from one class to another class to another class to get the data. And this is how you go like system.out.print something, right? If you remember that. School, student1, print something, get, set. Okay? So same thing. If I want to do exactly the same as that, I can say school1 dot school1 dot I want to get, I can get the name. We can set the name actually, right? I didn't set the name yet. You set the school name, gateway. I can set the school code, for example. Let's just say 1, 2, 3. So these are the data fields inside that school class. But the student, I cannot go directly to the student. If I do that, I will lose this connection. So I have to go to the school, go to the student object. In this case, I have a getter to get the student, and then it will reach over here and get this data. Okay, so you do like even to set the data. So you go school1 dot get student. You see that it's available, student1 dot, and then from there I can access the student class. So you have to go through that get student object method And then from there, I can say set the ID, 556677, and I can say student school1 dot get student 1, and then set its name. So now I set the school name, school code, I set its student ID and then its name. And then when you print it out to the console, you go exactly the same route, except you change it to the set, to the get instead of the set. So you can go to system out, school1 dot get name, so that will print gateway. And then system out, school1 dot get code. We'll call in the function the getter, and you can get the student ID from there as well. So school1 dot get student, have to go from that function and then get the student name ID. So it can be a lot of type, but there's no shortcut. So get student 1, get name, and that's how you retrieve data from the student class, which belong to the school. And here, I put it on here inside the print statement. Like here, if this is confusing, then you would put it into variable names. Okay, so you can say like string school name, right, is equal to that get school name here. You can put that here, like that, right? So instead of putting school1.get name here, I will just put the school name. I mean, just for printing that. So if it is easier to manage, you can do it this way. And same thing here. This part here could be replaced with just a student ID. So you can access that and print it out. So, but either way, you still have to get the ID from the student class through the school object, because the school is composed of that student. Okay, so this can be a little bit tricky, so just make sure you kind of follow the chain. Okay, so I'm creating a school here, and again, so how you return back to this diagram kind of help you. School 1, school A, is an object of the school class. The school class has an object of a student, and the student has a student class here. So to reach out to the ID, name, and grade over here, it goes school A dot get the student 1 dot get name. Okay. And if the student is composed of another class, you say dot get books dot get book name. Right? You can go down that chain there.